Hi friends, welcome to this channel. Here we are going to look at today's daily challenge problem, Partition Equal Subset Sum. This problem is now a very classic problem. It's related to 0-1 knapsack problem. The statements are the following. We are given an array called nums, so we are going to return true if we can partition the array into two subsets such that the sum of the elements in both subsets is equal. Otherwise, we return false. So in the first example, it's true because if you look at the total sum is 22. So half will be 11. So you have 1 11. Then the remainder has sum 11. So we return true. For the second one, so you see 1 plus 2 plus 3 is 6. 6 plus 5 is 11. 11 is an odd number, right? So you cannot equally divide the sum. So we return false. So here the constraints are the following. So the length is bounded above by 200, and the numbers are strictly positive and in between 1 and 100. So with that said, we are ready actually to do the coding. So we are going to do two solution formats. So the first one will be tabulation. So here we're going to write this version for digesting the details. And then we're going to write a recursive solution. So with that said, let's move forward. So in the first version, we're going to do the coding, and in between, we're going to explain the logical details. First, for convenience, I can get the sum of this nums list, right? So if s modulo 2 is not 0, so in this case, we should return false, right? This is the one. And then we are going to define a ck equals s integer division by 2. Because we have checked this if, right? So up to this line, 16, s must be even. So then we can do integer division by 2. So k is an integer. So now we want to do dp. So this will be a subset sum problem, or you can interpret it as 0-1 knapsack problem. So here I'm going to use 1D and dp. So here we're going to do this. So we are going to use true for 0 and then plus. So false times k. So in other words, so the dp will be the following. dpi is if we can make a sum I to be I, right? So the because here the dp array has length k plus 1, then if you count the index, it will be from 0 to k, both inclusive, right? So that will be the dp initialization. So now let's look at the update. So basically we are going to iterate for x in nums, and then we want to check all numbers. From k to x, right? Both inclusive. So but k we should see is larger than x, right? So from to check if adding x can make I, right? So this is the one. This is the main logic. So basically for I in range, so we should check only for greater than x, right? Because so here we are going to from k, then ending at x. So we write x minus 1, and then the step will be -1. Then dpi will be the previous one, logical OR with respect to dp I minus x. So this expression I minus x also explains that I is greater than or equal to x. So right, but we only consider up to k, right? So you shouldn't understand I as index, but it just as a number, right? So this is it. But if you interpret in the dp table, yeah, you can correspond to I. So in this regard, I should be from 0 to k, both inclusive, right? So once we have this, then let's do a early stopping, early return. So if dpi, in other words, if dpk, right? So if we in between, we can already make the sum key. So we just need to return true. We don't need to continue further. Otherwise, we are going to return dp -1 or dpk. So let's write dpk because this is more suggestive. So this will be the full solution to the problem. Now let's first run it. Yeah, it passes the 3 cases. Now let's look at the generic case. Yeah, it passes all the cases. So now before we move towards the second solution, let's look at one example. Let's look at this one, and we can print out those things. So after we update dpi, right? So so we can do this maybe. So print I can print out this dp table. So let's see. Because already it will already returned. Let's do this. Let me copy this one and then put it here. Right. So this way you can track the status of this. Actually, up to 11, you can already get the return, because 11 minus 11, the sum will be 11, right? The key will be 11, and 11 minus 11 is 0, but 0 is default to be true. Therefore, once you see 11, you should return. But 11 is the third, right? So you have 3 lines of output or prints. So this is the one solution. So let me delete this one. Also delete this one. So this way, from this solution, we actually understand the details. Now let's copy the part and then write a recursive solution. I'm going to call this one version v1. So this is iterative for sure. Iterative. And then for this one, recursive. So here still this will be the same, right? If you have odd numbers, you can return false. And then we try to construct this sum key using elements from this nums. So now let me write a hyperfunction. So I'm going to write as dfs, so index, and then total, right? So first is a bounding condition or base case. So if I equals, let me introduce this n, n will be the length of nums. So if I equals n, in other words, if your index is auto bound, so here we should interpret I as index, or the total is too large, is larger than the key, so we should return false. So this is the bounding condition for the base case for the recursion. So next, what we are going to do is this: if total equals target, in this case, because for sure we have already checked this if, then the only possibility is I is less than n, right? In other words, inbound, and also total will be less than or equal to key, the target. So if this equals the key, so we're going to return true, right? And then let's look at the recursion call. So otherwise we're going to return dfs. So we can choose to use the current number. So then this will be total plus nums I. Or we can choose not to use it. So it will be I plus 1, still total, right? As long as one of those is true, we are going to return true. So this will be the major hyperfunction. So here I'm going to use cache. This is a decorator, right? So what we are going to do actually will be call dfs starting from index 0 and 0. So this essentially, the formats are different, and if you look at it, you dig into the logical details, it should be the same as this one, the first one. So now let's first run it, right? Yeah, it passes the 3 test cases. Now let's look at the generic case. Oh yeah, it passes all the cases. So with that done, I guess we finished also the recursive format. So with that said, I guess we can make some comments. First, for this problem, here I'm in the iterative format, or in the tabulation, I wrote 1D dynamic programming. But if it's the first time you do such problem, you should consider using 2D DP to understand every single detail. So this is the first comment. The second comment is the process. So here we first write a recursive, iterative solution, and then recursive solution. So the logical process is that I use tabulation for details, then I use recursion for compact coding. So this is the second comment. The third comment is that in our channel, so we have a DP, dynamic programming playlist. You're welcome to check out those videos to practice. With that said, thank you for watching.